All right, welcome once again. Today we're going to talk about how to look at a graph of a sinusoidal function, which is your big word of the day, and be able to get the information out, find the period and the amplitude and all the other parameters, and then be able to write an equation. So this is the first example I'm going to do here, and I'm going to jump right into it. You should know the vocabulary that I'm going to use. Amplitude, period, phase shift, vertical shift, something that I call the equator, and the general form of what a sinusoidal function looks like. And I'll go and write that up on top here real quick before we get started. So the format is going to be f of x equals a sine or cosine, and we'll get to that in a few minutes, b x minus k, plus k. So that's going to be our format that we're going to use for our final answer. Okay. So when we went the normal direction, when we went from an equation to a graph, we listed out our a, b, h, k values, and we found our period, and we figured out how to label our tick marks, and then we kind of did the pattern based on that. This is going to be a little bit different, though. So on this one, what I want to do, I want to find the amplitude and the equator kind of at the same time. So we know our amplitude means the height from the equator, or we could think of it also as the total height of the whole thing divided by 2. And if you notice on this graph here, my minimum height is at -3. My maximum height is at 5, so that means that total distance here is 8, which means my equator must be 4 units down from the maximum or 4 units up from the minimum, and that puts me at +1. And if I draw a dotted line right through +1, sure enough, that is going to chop that graph in half. And so that's why I call it the equator. Is that, and also I just answered 2 of these blanks. So my amplitude is 4, because it's going up or down 4 to the maximum and minimum points. My amplitude is 4. And my equator is just whatever that y value is that it goes across. So my k value, which is the equator, is +1. Now I've got to find the period. The period can be tricky sometimes, because for the period, we need to go either peak to peak, which is what a lot of people do most of the time because it's kind of easiest visually to do. We can go bottom to bottom, which in this case, I don't even really see the final bottom, I don't think. Or we could start here on the equator as long as I do one complete cycle. So I could go from this point all the way to this point here. Either way you want to do it. But I'm going to use peak to peak. Okay? And this usually involves a bit of math. So we're going to take the right-hand side minus the left-hand side. So my right-hand side is 5 pi over 2. Minus the left-hand side, and that's minus -3 pi over 2. Watching your signs, this comes out to be +8 pi over 2, which I can simplify to 4 pi. So my period is 4 pi. Now, if you remember from, again, going from an equation to a graph, we knew that the period equals 2 pi over b. So I can use that same equation. So I can say that 4 pi, that's my period, must be equal to 2 pi over b. And doing a little bit of algebra to solve for b, b is going to be equal to 2 pi over 4 pi. And that will simplify out to 1/2. So my b value is 1/2. Okay? So again, to find the period, I use peak to peak. Right side minus the left-hand side, watching the signs, simplifying. And then once I know my period, I just use my equation from before, the period equals 2 pi over b, simplify that, and so my b value is 1/2. Okay? Now, as we move forward here, so what we got to do now, and this is where different people in the class can have different answers, different final answers for the equation. Because you have to tell me, or tell whoever your teacher is, where are you going to start? You have options. We can use our starting point anywhere that the graph hits the equator, or we can use either of the maximum points, or we can use a minimum point. It is 100% up to you. Okay? I'm going to use this point way over here on the left-hand side, negative 5 pi over 2, just because I feel like it. And I'll explain the difference if I had used one of the other points in just 1 minute. Okay? So I'm going to use my point right here, negative 5 pi over 2 and 1. So I'm going to put a big old dot right here so I know what I'm talking about, and if I were to turn this in on the assignment so my teacher knows what's going on and stuff like that. So my starting point, negative 5 pi over 2, comma 1. And that means, if I'm choosing that as my starting point, that means my phase shift, my horizontal shift, is that x value. So, in other words, that is my h value. And now I'm ready to write my equation. That's all I needed. Because now I go to my format, f of x equals, I know my a is 4. And since I started on the equator, I'm going to use sine, because I know that's where my parent function starts. Parentheses, my b value is 1/2. New for the parentheses. And then I do my h value. Again, since I'm going left, it's going to be x plus 5 pi over 2. Close all the parentheses. And then my equator was plus 1. And that would be a 100% valid and correct equation for that graph. Now let's talk about, for just a minute, what if I had chosen one of the other points? What if I had chosen this point up here at negative 3 pi over 2? Well, that would obviously change my phase shift to negative 3 pi over 2 and my starting point. But how would it change the equation? Well, if I'm starting at a maximum, now I would use a cosine. So I could also write this, I'm going to put this below here, I could write this as f of x equals 4, amplitude doesn't change, cosine 1/2 x plus 3 pi over 2 plus 1. These will generate the exact same graph and look exactly the same. Notice, anything you do, the k value is always the same, the amplitude is always the same, and the b value is always the same. The only thing that changes, depending on your choice of the starting value, is what the h value is, the phase shift, and if you're going to use sine or cosine. If you start on the equator, you'll use sine. If you start on a maximum or a minimum, you'll use cosine. Now, the last thing I'm going to say is about the amplitude. Again, that also affects where you're starting. Since I chose that point and it goes up, my amplitude, my a value is going to be positive. Or on the second one, I chose a maximum, so my a value is positive. Notice, if I had chosen this point right here at negative pi over 2, it's still on the equator, that's still legal. But now, since it goes down, I would have used negative 4 in front. Or, one more, if I had started here at positive pi over 2, notice my positive pi over 2, it's at a minimum value, so I could have used cosine with also a negative 4 since it starts at a minimum. Okay, so just on this one graph right here, you could have 1, 2, 3, 4, 5, 6 different correct answers based on your starting point and based on where you want to start your graph at. Make sure, whether it's from me or any other teacher, make sure that they know where you are starting. Okay? So if you need to pause the video and go back and take a look at that, I'm going to show you one more example that you can do on your own. And you can pause the video and I'll walk through that in just a minute. So here is another example. So I'm going to leave that up there. Again, pause the video for a second and take a good look at that. See if you can find all of the values. Choose your starting point. And then write the equation. Okay. Hopefully by this point you've filled everything in and you can ready to see what the solution is, or what one of the solutions is, because there's a lot of them. I'm going to go through this a little bit faster. So amplitude, we know it goes from -5 to +1. So the total distance is 6, divided by 2 is 3. So my amplitude is 3. And my equator, again, must be down 3 from here. So 1, 2, 3, or up 3, 1, 2, 3. Sure enough, it's at -2. And I'm going to draw that dotted line just so I can have a visual of that. And sure enough, it chops that thing in half. My period, this time is kind of nice because this time I got nice clean numbers instead of dealing with all the pi's on my x-axis. And again, I'm going to go peak to peak. So I'm going to choose this guy right here and this guy right here. And it looks like that's at 19 and all the way to -1. So 19 minus a -1 is 20. That's my period. And for the b value, I know that 20 equals 2 pi over b. Doing a little bit of math there, that would mean b is equal to 2 pi over 20, or pi over 10. Okay? That would be the same for everybody doing this problem. The k value, the amplitude, the period, the b value, anybody looking at this graph would have to get the same values. Okay? Now it's time to choose our starting point. I'm going to choose this time, what do I want to choose? I'm going to choose this point right here, because I want to make sure you guys see how it's a reflection. If you're starting at another point, I'll explain some of those points in just 1 second, but I'm going to use this point right here. So that point is 9, -5. So that means my phase shift is whatever that x value is. So it's 9, and that's my h value. And I'm ready to write my equation. So f of x equals, now in this case, my amplitude is 3, and I'm starting at a minimum. So it's going to be -3, and it's a minimum, as I just said. So it would be a cosine, parentheses, pi over 10, my b value, x minus 9, change of sign, -2 for the equator, for the k value. I'm going to go through a bunch of these kind of real fast, so you're not here all day. If you chose this point, you would do +3 sine, and then this would be positive 28 or 26. I'm sorry. This point would be positive cosine, so 3 cosine. This point would be -3 sine, -3 cosine, +3 sine, +3 cosine, and I think you kind of get the handle of what else is going on here. So again, anything starting in the equator would be a sine function, going up positive, going down negative. Anything starting at a maximum or a minimum would be a cosine function, maximum positive A, minimum negative A. I do hope this helped you. This helps you knowing how to write an equation from a graph. We will be doing some more of these in class, and if you need some more practice, by all means, let me know. I will post links to my previous videos on how to graph a sine or cosine function if you still need some work on that. And please, if you want to be updated on when new videos come up, feel free to subscribe. Thanks again for watching.